Hello everyone. Now we are going to discuss about the second application of deep learning, that is computer vision. So this is the second topic. This also you can find that in the deep learning textbook. And now computer vision. Let us talk about the general way of computer vision. In general, if you see something, you can understand what it is. If you see some object, you can understand what it is. But if the computer sees that, how it can understand? Meaning that if the computer can also understand, not only the computer, the machine, if the machine is seeing something and if it is able to understand what it is, and if it is able to react based on the content it has seen, then it is called the vision. Vision means whatever you are seeing, that if you are able to understand, that is called the computer vision. Now we can react. Actually, if you see something, then you will react based on the visual, whatever you have seen. Now the computer vision means computer will see and understand and then react based on that. Again, in this there are various ways of handling the computer vision, and not only the computer vision, the machine vision, we can call it as the machine vision. Actually there are some traditional techniques also available for the computer vision with the image processing, image analysis techniques. And whenever we entered into the AI and machine learning and deep learning, then it has taken a very big achievement that we are able to understand the vision in the higher level and we can take the decisions, and it is very useful in so many areas, and either in the medical field or in the satellite or anywhere. There are so many applications are available that we are going to discuss in that. In the before AI and machine learning, deep learning, we have to understand the edges. Based on the edges, it may be the horizontal edge, vertical edge and diagonal edge. Based on that, we were able to understand the images and then take the decisions. That is the past. Now we are in the deep learning and generative AI era, so we are going with the computer vision with the deep learning techniques. Now core areas of the computer vision, actually it was not mentioned in this slide, and classification, image classification. If you see one image, you can identify whether a particular object is available in that image or not. Let us say for example, in this image a particular person is available, a person is detected or not, whether the hall is empty or full. Like this, there is some classification. If the image is having the dog, cat, or whether it is having some flower, what is the kind of flower in that image? It may be the marigold or some other type of flower. So classification of the images, based on the domain. Of course, if you give the chest X-ray image of the pneumonia patients, whether based on that image, chest X-ray image, it has to, our model has to identify, classify whether this patient is infected with the pneumonia or not. Again in the pneumonia, whether it is the bacterial pneumonia or viral pneumonia. So like that we can classify, that is the classification model. So that after the classification model, we have the object recognition and detection. Object detection and recognition. Object detection means whether this particular object is available or not, that is the object detection. Object recognition, meaning that what is that object? Let us say for example, whether a person is available or not, that is the object detection. Object recognition, in this particular frame where he is available, where this particular object is available, the region. If you are able to identify the region, then it is called the object recognition. And then optical character recognition, this is the character recognition, meaning that if we have the text format, text data, we can take the snap of the text data and we can train the model to digitize that, so that if you have the handwritten text, handwritten information, that can be computerized and digitized and you can get the digital data, digital document for the handwritten document. So that is also another application. And image segmentation, this is very useful for the medical field and also for the autonomous cars. In the medical field, let us say for example, if there is a CT scan or MRI scan, whatever the images, if you have that, the infected area can be masked with a color, or uninfected area can be masked, meaning that the infected area can be colored with one color and other can be filled with some other color, so that we can easily identify where is the infection exactly. So that is the image segmentation, that is the masking of the image for different classes. And of course autonomous driving, for driving also we have to understand, we need not understand what is that object and react, whether the road is free or not for the autonomous car driving. So whether the road is clear or not, whether is there any object or not, if the road is colored with one color, filled with one color, then it can take the decision that whether it has to go forward or not. So that is the image segmentation. And image synthesis, this is the generative model, meaning that we can generate the missed items in the image. Let us say for example our old photographs, if you have the old photographs, that photograph may be spoiled because of some insects and all, so that we can reload that, recover that image by filling the part of the body. So actually previously we had to do that with some other tools like Photoshop and all, but we have the computer vision concept, and the generative models we can regenerate the images by filling the missing objects also. That is and you can generate the new images, new faces. Already we have discussed about this in the GAN concept. For that, the GAN, variational autoencoder, all these are the various examples for the image synthesis. So and now we have to go with the next one. Processing. For image analysis, we have to go for the pre-processing, meaning that if you have one image, of course it may be the video or image. The video is the collection of images, collection of frames, that is called the image. Now if you have one image that has to be pre-processed, that has to be processed before entering into the model, so that is called the pre-processing of the image. There are several steps in the pre-processing. Already we have done that in our image handling techniques in 4th unit. So in that standardization, already you have done that. Actually the image pixels are having some values, the values may be from 0 to 255 or it may be from 0 to 1. So anything is possible, anything is allowed, but beyond that it is not allowed. So here we have to scale the images, pixels of the images between 0 1 or 0 to 255 or -1 to 1, because we have some activation functions like sigmoid and tan h. If you are taking the -1 to 1, you can use the tan h very easily, so that we have to scale the image pixels with some fixed values, that is the standardization. And also we have to go for the size, we have to resizing and cropping of the images. Resizing means if you take the bunch of images, let us say for example 100 images, all these 100 images need not be with the same size. One image may be 250 by 360 or some image may be 512 by 50, like this the images may be having different sizes and different size of pixels also, different pixels also, so that we have to standardize that and we have to resizing into the same size for giving into the model. So adjust the image dimensions and also the sizes, and also we have to go for the cropping of the images or padding of the images. Let us say for example, if you have a very small image and very big image for the training, if you consider only the small image and if you compress the big image into small image, you may lose some data. Instead of that, you have to pad the small images to reach the size of the big image, so that you can train the model with this padded images. And of course, we can go with different techniques. And dataset augmentation, this is another technique, dataset augmentation. Here let us say for example, if you are going for the autonomous driving, in the autonomous driving the objects has to be recognized, what is the object on the road, and that object can be trained in one dimension only. Let us say for example, if there is a person, there is a dog, in that particular dimension, we can give only in one dimension. But if the person is fell down on the road, then if you train with the standing person the model, and if on the road, if the person fell down on the road, it cannot recognize, so that the vehicle will not stop, it will go. Meaning that we have to understand the dimensions, various dimensions and various angles also. How can we achieve that? By using the data augmentation, meaning that you can rotate the picture, rotate the image and flip the image, and you can have the different levels, different locations also. You can place the images, and then you can give that pre-processed data with these augmented data to the training model, so that to train the model, so that it can understand, it can detect the object in any angle, so that it can be useful for the most important applications. So that it is for the real world variations, this is for the real world applications, like whatever I explained now. And for the medical images also, tumor, the tumor may be with different angles, it may be in the different angles, it may be with different sizes, different locations of the frame, we do not know that. So that we have to go for the augmentation. And now the computer, again in that there is the contrast normalization. We have to adjust the contrast, brightness and contrast. The contrast can be also normalized by applying the mean of all the pixels on the each pixel. So that is, see here, there is a global contrast normalization and local contrast normalization. These are the two techniques. The global contrast normalization means if we have the 32 by 32 pixels, meaning that you have to take the mean of all these 32 by 32 pixels and subtract that mean from the each and every pixel. You can see that this is the 3 channels and number of rows, number of columns, and there are 3 channels, and we are applying the xijk, meaning that each and every pixel, we are applying each and every pixel minus the mean, and we are making it square, and again we are applying the square root also, so that we are stabilizing the contrast on the image. It may be having some lighting from one side of image, and it may be the dark from another side of the image. We can adjust that by using this global contrast normalization, and local contrast normalization is also there. We will take the regions, we will apply the same technique on the local regions. We can divide that into regions, and on the region we can apply this. And there is the mathematical explanation that is having this, and this will be the detailed mathematics will be provided in the material. And image synthesis and generative models, already we are going with that. We have done the GANs and autoencoders in the 4th unit, and we have executed some exercises also. So generation of the images, we have given the introduction and a detailed explanation in the 4th unit. So we need not discuss much about that. The popular techniques for the generative models are GAN and variational autoencoders. After that, CLIP and DALL-E are also there. So these are the using to search the images, related images for the given text, and the DALL-E, if you give the description of the image, that will generate the complete image and it will give it to you. So these are the two other techniques, advanced techniques. They are not covered in our syllabus. In our syllabus we have the GAN and auto encoders. We have completed that. Thank you.